This is the Integrated Math 2 Chapter 13 test review, and just number 63. And 63 is on your review. It's going to be a large table. So you'll notice on this table, let me just kind of go through this here. We have standard form, then we have factored form, we have vertex form, and then we have the graph. And we're going to need to use what we're given and then find the factored form, vertex form, and then graph everything. So let's go through and see if we can do this. All right, we're starting in standard form. We want factored form. Well, that's not too bad. Let's just try to factor it right underneath, and it might make it easier for us. Some of you use the box method, others just trial and error. Well, we can use trial and error. Here's x and x. And how about we go 7 and 3. We need more positives than negatives, so that's going to be a positive 7 and a negative 3. All right. So there's my factored form. We'll enter it up here. Y is equal to x minus 3 and x plus 7. Now down on the bottom, let's take a look at the y-intercept they want in this column. Well, the y-intercept is always your c value, negative 21. So we're going to write that as 0, comma, negative 21. Factored form. Well, factored form, you'll notice here, let me get a little arrow going. These have a direct relationship to your zeros. So this is really x is equal to 3, and this is x is equal to negative 7 if you use the zero product property. All right, that's how we get those two zeros. Well, the zeros would be, I'm going to write them in x-intercept form for now. You could write them as x equals 3 and x equals negative 7, but we're going to go 3, comma 0 and negative 7, comma 0. Vertex form. Well, in order to provide the vertex form, I have to start in standard form, and then what I have to do is I have to complete the square. So I'm going to rewrite standard form. And I do notice, so just pay attention here, look at this negative 21. This is not a perfect square. And I need this entire trinomial to be a perfect square trinomial because that's what completing this square really means. So I'm going to move this negative 21. So I'm going to add 21 to each side. I have y plus 21 is equal to x squared plus 4x. Now you have to kind of ask yourself, what am I going to add here so this is a perfect square trinomial? Well, we're going to add half of 4 squared, which is going to be 4. And I need to add 4 onto this side. This becomes y plus 25 is equal to, now this is going to be a binomial squared, so this is going to be x plus 2 all squared. And let's subtract 25 on each side. I have y is equal to x plus 2 all squared minus 25. And now you can see here we've got a 2 and negative 25. There's your vertex, and just be careful, it's going to be negative 2 comma negative 25. And the graph, well, let's just graph this thing. It's just kind of a rough sketch. We will go, how about 1, 2, 3, 4, and 5, and 1, 2, 3, 4, 5, 6. All right, there's out to 7. And I see we have a vertex here of negative 2, negative 25. So if I go negative 2, negative 25, let's just say this is negative 25. So maybe that right there would be the vertex. Looks like I have a y-intercept of 0, comma negative 20. So let's just roughly sketch. This is negative 21, let's say. I have x-intercepts of 3 and negative 7. So here's 3 and negative 7. So we're going to go 1, 2, 3, 4, 5, 6, 7. And all you have to do now is kind of draw through and sketch through your given information. There's the graph. Now, just be careful here. They're asking for to label the y-intercept, the zeros, the axis of symmetry, and the vertex. So let's label this axis of symmetry. I'm going to draw it in here. All right, let's move that slightly. So let's move this. It should be over about right here. Now that axis of symmetry is x is equal to -2. So there's your axis of symmetry. All right, that was starting in standard form. Let's go to the next row. We are now starting in vertex form. So we need to go to vertex. We've got vertex form. Let's first take vertex form into standard form. Now, how are we going to do that? Well, watch. So y is equal to, we have x minus 5 all squared minus 49. So this really becomes the following. Y is equal to x minus 5, then times x minus 5 and minus 49. Let me zoom in for you. There we go. We are going to distribute. This will be y is equal to x squared minus 5x minus 5x and then plus 25, and then tack on this minus 49. So we have y is equal to x squared. We can combine like terms, minus 10x. And then combine again like terms. That's going to be minus, and you've got 25, negative 49. That looks like 24. All right. So there's your standard form. Okay. Let's go ahead and try to factor this. So I'm going to start in standard form, though. We've got y is equal to x squared minus 10x minus 24. Here's our x and our x. And that negative 24. So how about we try, we could try 12 and 2. Try 12 and 2. We need more negatives, so negative 12, positive, and that should do it for us. Now let's fill in all this important information. For a y-intercept over here in the standard form, the y-intercept is always your c value, so that's going to be 0, negative 24. And then over here we're asking for the zeros. Well, we know the zeros are going to be, we've got x is equal to 12 and x is equal to negative 2. So the x-intercepts are going to be 12, 0 and negative 2, 0. We definitely can get the vertex from vertex form. This is 5, 49. 5, negative 49. And let's go ahead and graph everything. So 5, negative 49. Now it's just a rough sketch. So we're going to go out to 5 here. Let's do this. Let's say this is 5, 10, and 15. Negative 5, negative 10, negative 15. And let's come down. Let's say this is negative 25. And how about negative 50? We'll say this is 25. All right. Let's graph the y-intercept, negative 24. So about right here, you can see right about there. Next, let's graph these two x-intercepts, so 12, 0, probably about right there. And then negative 2, 0, maybe about right here. Okay. And then we have we have 5, negative 49, so we've got to go 5, negative 49 is about right over here somewhere. And you can see, I mean, my points are not perfect, but this is just really a rough sketch. All right, so that's going to be the vertex. And let's trace through this. That's going to be approximately what it looks like. And our axis of symmetry, here it is. That axis of symmetry, very important that you label it correctly. So your axis of symmetry would be x is equal to, well, 5. Next. All right, on this one we're starting with standard form. So what I'm going to do with this standard form, okay, right here, I'm going to first take it into, this factored form. I'm going to change it to standard form. Let's perform some FOIL here. So y is equal to 2. We've got x plus 3, and then we have x minus 5. All right, this is going to be y is equal to 2, and I have to distribute, right? So let's do that. We'll zoom in for you here. This is going to be x squared and minus 5x plus 3x minus 15. Here's what we have. We have y is equal to 2. And let's combine some like terms here. This is going to be x squared minus 2x and minus 15. And y is equal to 2x squared. And here's what I'm doing. Let me bring you through. I'm distributing, okay? 2x squared minus 4x and then minus 30. So there's standard form. Now we need to take standard form and complete the square. All right, here we go. This is going to be a little intense. So, all right. In vertex form. So we're going to start with y is equal to, and this is going to be 2x squared minus 4x and then minus 30. All right, now keep in mind you don't have to complete the square to do this. You really don't. I want to quickly show you something. From this factored form, do we agree that this is x is equal to -3 and x is equal to +5? Well, those are the x-intercepts. So if you average those together and find the middle, then you're going to find the axis of symmetry. And that's not bad. All we have to do is -3 plus 5. And we're going to cut that in half, and that's going to be 2 over 2, which is 1. And then if you take this 1 and you plug it back in, okay, you're going to then find the vertex. Let's just quickly do that. This is going to be y is equal to 2. It's going to be 1 plus 3 and then 1 minus 5. So y is equal to 2 times 4 and then multiplied by -4. That's y is equal to 16 times 2. That's going to be -32. Well, I know the vertex already. Okay, this vertex just happens to be 1 comma -32 is my vertex. Now, you can complete the square, and it's probably worth my time right now just to complete the square on this to show you. And we're going to do that. So I'm going to add 30 to both sides. I have y plus 30 is equal to 2x squared minus 4x. Now I cannot just divide the 4 in half and then square it because this needs to be a 1. So I'm going to factor out a 2. Remember, that's your dilation factor, so you don't want to just lose it. So this is y plus 30 is equal to 2. And what's this going to become? X squared minus 2x. Now I can complete the square. Here goes. So y plus 30, intentionally leave some space, is equal to 2 multiplied by x squared minus 2x, intentionally leave some space, and inside here, think about this. What is half of 2? That's 1, and then square, and that's 1. So add 1. Now, watch this. This is just going to be the critical point to completing the square. If I add 1, then I'm wrong. That is incorrect. Let's get rid of that 1. Now, listen carefully. I didn't just add 1 to the right side. I added 2 times 1 to this side. 2 times 1. You have to distribute. If you do distribute 2 times 1, well, we added 2. So in order to balance things, I have to add 2 over here. All right, so I have now y plus 32 is equal to 2. And we know this is going to be a binomial squared, so x minus 1 all squared. Just subtract your 32 on each side. And look, we have now vertex form. And vertex form, look, this is going to be 1 comma negative 32. And it's the same exact thing. All right, let's zoom back out and let's take care of some of these important characteristics. The y-intercept is negative 30, and more importantly, it's not just negative 30. It's going to be 0, comma negative 30. The zeros, well, we already found them, but it's going to be negative 3 comma 0 and 5 comma 0. Those are the x-intercepts. Okay. The vertex happens to be 1 comma negative 32, and you can see it. We've done it 2 different ways. And now let's graph this thing. So after I kind of scan all the points I need, how about let's go by 5. So we'll go 5, 10, negative 5, negative 10. I need to go down to at least negative 32. So let's go down by 10. So negative 10, negative 20, negative 30, and negative 40. That should do it. And how about I start with this vertex, 1 comma negative 32. So we're going to do 1 comma negative 32, probably about right here. There's my vertex. These two are my zeros, so negative 3, 0. So negative 3, 0 about right here. And 5, 0 is about right here. The y-intercept, well, here's my y-intercept, 0 comma 30 about right here. I'm going to go ahead and zoom in. So tracing through this, here is your parabola. Now we need an axis of symmetry, so we use a broken line to do that. All right, let me move that over a little bit. So about right there. And your axis of symmetry, okay, is really just comes from here. Here's your axis of symmetry, it's 1. So x equals 1. Okay, we move forward. Here is our next one, and you'll notice I have not given you the standard form, factored form, or vertex form. I've just given you the graph. Now, on the printed version, I did say we're going to let the dilation factor and which you know is A, we're going to let that equal 1 on this one and make it a little bit easier for us. Well, if you kind of look pretty closely, this here, that is a vertex, and that happens to be negative 5 comma negative 9. We also have an x-intercept, that happens to be negative 2 comma 0. And this one happens to be, let's count this out here, negative 1, negative 2, negative 3, 4, 5, 6, 7, 8, negative 8 comma 0. We've got a lot of information here. We also have an axis of symmetry. So our axis of symmetry, how about we'll include it right here. All right. Let's see what we can do. How about I'm going to start with vertex form. So I know the vertex. The vertex is negative 5 comma negative 9. And I know my a value is equal to 1. Well, here we go. Y is equal to a times x minus h all squared plus k. So this is going to be y is equal to 1 times x minus, well, look what the h is. The h is negative 5, so this is going to be plus 5 all squared and then minus 9. There's vertex form. And factored form. Well, factored form, we have two x-intercepts, negative 8 comma 0, and we have negative 2 comma 0. So you could think of those, I know in my class we use p and q, you don't have to, but we have y is equal to a times x minus p times x minus q, and this is going to be y is equal to, well, this is a 1, and we have x minus negative 8, so I'm going to go plus 8, and then x minus 2 or x plus 2. There's your factored form. Standard form, well, all you have to do is take one of these and distribute. So why don't I do this? Y is equal to, I'll start with factored form. So y is equal to, this is going to be x squared plus 2x plus 8x plus 16. So y is equal to x squared plus 10x plus 16. All right, let's identify this y-intercept. That's 0 comma negative 16. The zeros are really just x equals negative 8 and x equals negative 2. The x-intercepts are negative 8 comma 0 and negative 2 comma 0. The vertex is negative 5 comma negative 9. You were given that. And we have everything done. Oh, one more thing very important, that I label this axis of symmetry. This axis of symmetry is x is equal to negative 5. And that is extremely important. All right, I believe this is our last row, and here it is. This one gets a little tricky. And on the printed review, once again, I said, let's let the dilation factor, in which you know is a, let's let that equal 1. All right, looking at the graph. Looks like I have an x-intercept of 0, 0, but if 0, 0, you know that this is an x-intercept and a y-intercept. Okay, so that's an x-intercept and a y-intercept. That's what that is. I see this point over here that looks like it's going to be 2 comma 0. Right, that looks like it's an x-intercept. I probably can write this, how about in factored form? Let's do that. Factored form, y is equal to a times x minus h, and then times x minus, not h, I'm very sorry there. Let's do x minus p, and then how about x minus q? Whatever those are, p, q, doesn't really matter. So y is equal to, the a happens to be 1. I've just let u equal, right? We've assumed that it's 1. This is going to be x. How about minus 0? That's because that's one of the zeros. And then finally, x minus 2, because that's the other x-intercept, or the 0. So we have factored form. That's done. Now, vertex form. Here's what you're going to want to do. I know that you're going to be you cannot assume. So I'm going to write that note here. Can not assume that it's 1 comma negative 1. So what we're going to do in vertex form is, you'll notice right here I have these x-intercepts, right? So I have 0 comma 0 as an x-intercept, and I have 2 comma 0. So let's find halfway between. So you would just do 2 plus 0 divided by 2. That's going to be 1. We'll take this 1 and plug it back into the factored form. So here's what it's going to look like. So y is equal to, we have the a is going to be 1, right? So I can just get rid of that. going to be 1 times, and let's plug that 1 back in. So I want to make sure that you can see what I'm going to do here. I'm going to plug in 1 and 1. Let's make those different colors. So 1 and 1. So this is y is equal to, well, in the first parentheses, that's 1 minus 0 is 1. And then right here, 1 minus 2, that's negative 1. So y is equal to negative 1. So guess what you've just done? You have just found the vertex. The vertex happens to be, and almost like we assumed, right? It's 1 comma negative 1. Vertex form is y is equal to, well, the a is a 1. We've got x minus, and that's going to be 1 squared, and then minus 1. All right, so there's your vertex form. Now, as far as your, you know what I should do? I should definitely write this. In factored form, we're going to write that this is going to be, well, what's x minus 0? That's just x, and then times x minus 2. That would be even better. Standard form. Standard form, why don't we start? Let's start in factored form, which is x times x minus 2. And let's see, we've got y is equal to, let's distribute. That's going to be x squared minus 2x. And look at this, plus 0. And remember, don't we have a y-intercept of 0, 0, so it works out great. So we have y is equal to x squared minus 2x in standard form. Perfect. Okay, y-intercept is 0, 0. The zeros are 0, 0, and 2, 0. Those are the x-intercepts. Vertex is going to be 1, negative 1. We have one last thing to do, and it's usually something that I've just forgotten. But let's go ahead and draw in this axis of symmetry. Okay. That axis of symmetry happens to be, this is going to be x is equal to 1. And that is it.